Are estimates useless, or should we just pay more attention to them and do them better? This is what we'll discuss today, starting from a set of very thoughtful comments from one of our viewers. Yugr, Y-U-G-R. Welcome back to Think Design Works Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And as I said, today we are talking estimations. This is a favorite topic for many people because it's still a very complex and difficult topic to discuss because it has a lot of various connotations, a lot of history, a lot of baggage. But it was very interesting to see these comments from Yugr in response to the video Fundamental Issues with Metrics with Sleepy Fox. This is an older video where we discussed the McKinsey proposed model for metrics, and Sleepy Fox made the case that we cannot measure developer productivity. And that's what's in this video. It was very interesting, quite illuminating, but on the other hand, we also got an interesting reaction. So let's talk about that too. I'm gonna read the comments first, exactly as they were, and then I will go back and reply, add a little bit of context, and then reply to and react to the comments of our viewer. So the first comment was disappointed to see people still hold to Luddite no estimate dogmas. And my answer was we'd be happy to discuss counter arguments as well. What we took from this conversation is not so much about no estimates, more about the fact that it is fundamentally difficult, if not impossible, to measure productivity in software development. As for the estimates, from our experience, the teams using no estimates are very different from the average enterprise team. An example of such context is that when the incentives are around solving business problems end-to-end, when the problems are prioritized and when they are treated with focus, estimates become waste. Practices in software development are highly contextual. But I invite you to share arguments rather than disappointment. We might all learn something new. And then the answer 1 month ago was split into multiple posts. And let me go through all these. Thank you for detailed and welcoming replies. Sadly, YouTube doesn't let full comment through, so let me try split it in parts. In my opinion, software development is not at all different from other highly structured human activities that deal with high risks, e.g. military art, and which are based on careful and continuous planning and estimation. The sad state of current software metrics and estimates is not an excuse to abandon it. Are single point metrics inadequate and most often useless? Sure. That's why we need at least interval estimates as first approximation of tasks' probability distribution. Do estimates quickly get out of date as new information is discovered? No doubt. That's why they need to be continuously updated. No, this does not take much time. Can technical risks ruin the projects and render all planning effort unnecessary? Of course. That's why in addition to estimates, we need to estimate risks and schedule tasks to reduce overall project risks ASAP. Can projects that consist of multiple tasks miss milestones because of accumulated deviations in all tasks? Sure, that's why we should do Monte Carlo simulations of network diagrams to obtain reliable confidence intervals. Is software development a highly innovative activity which deals with new domains and high risk? Well, maybe, sometimes. Personally, I'd say modern corporate developer experience is this 5% of his time at best. And I work on compilers, so not the most trivial domain. These are the important questions which need to be discussed in context of metrics, unless we just want to increase the world's entropy. Finally, from my experience, teams that actively disregarded estimates on the ground of agility, business orientation, and other popular cliches were, well, not the best. And then my answer was, this set of replies deserves its own reaction video. I'm not promising, but I estimate we can get to it in December. And so here we are. We just got to it. All right, let's first set a little bit of context. I think the way I want to frame this is that estimate is a tool in a set of toolbox that we use in order to deliver software according to the needs of the business or to our own needs, whatever might be. But let's assume we are working in a business. We need to deliver as the business needs. And we have a set of practices. And we pull from those practices the ones that fit our specific context. Now, depending on your context, there are contexts where estimates add value, and there are contexts where estimates not only don't add value, but actively increase your opportunity cost. So you spend time estimating that you could be spending building software, delivering something even better, delivering business value. Let's put it this way. Because our goal is not necessarily to build software, it's to deliver business value. And let me give you one example where estimates, I have at least 2 examples that I can give. One example is the team that created the BDD technique, behavior-driven development. What they were doing is they were working on complex financial packages, and often they didn't have specifications because the way the domain experts would figure out what needs to be implementing is by seeing the implementation and giving feedback to it. So the algorithms were so complex that you actually needed this back and forth. Okay? And in this context, what they ended up doing is pair programming between the domain expert and the programmer, and they needed a way to translate what the domain expert wanted in a language that the domain expert understood, so they ended up doing behavior-driven development. So this is a context where you could try to estimate, but the estimation error would be so high that estimates are meaningless. And I'm not saying this is 100% of the industry, by the way. This is one, perhaps very small part of the industry. I don't know how to estimate this. But I want to give this as an example of a context where estimates introduce opportunity cost. So instead of actually working the problem, what you're doing is trying to estimate, trying to take into account all the risks, all the issues, and so on. And you get nothing, no value for that estimate, because the risks, the error for the estimate is much higher than the estimate itself. Another example is a company called Unruly, where what they were doing was advertising campaigns for online customers. And this meant that often they didn't actually know what to implement. And it was again a continuous conversation between the team, the technical team, and the client, figuring out what the next step would need to be. And this is an example where they used extreme programming to solve this, and they took extreme programming all the way to the product side. They were actually doing product management without product managers. Another context would be the context of a startup that is trying to figure out product market fit. And the way you do that is by running a lot of experiments. So you might implement certain prototypes or certain features that you show to certain parts of your potential audience. You try to get feedback, and you get to the point where you figure out what it is that you actually need to build, what is the actual problem that you need to solve. This is another context where estimates, in this case, can be valuable because you are running on money, right? So it would be valuable to know kind of how long you need that, how much are you willing to invest into one experiment over another. But the level of estimate that you might need is just order of magnitude, right? I mean, you could say this is small, medium, large, and so on. Kind of figure it out like that, instead of trying to put numbers on it. Because you'll have an error. So in that case, again, what's more important is to run as many experiments as possible, to answer as many questions as possible, in order to get to the point where you have this clarity of the problem that you're trying to solve. And from here on, estimates are more valuable. But until you get there, it might not be so much. And now this is the challenge that I think many developers have. If you are working in a more stable domain, where the requirements are clear and you have this notion of requirements, first of all, then of course you can say that in this situation you can actually apply software estimates and they bring value. Because that is correct, with a few exceptions, and we will discuss those exceptions as well. But people who work in these areas tend to completely ignore the areas where the notion of requirement itself makes little sense. Because really you don't have requirements, you might have questions, you might have experiments, you might have attempts to solve a problem. You might not even know precisely what problem you're trying to solve, and you kind of try to figure out what the problem is by asking a set of questions, so through a process of discovery. And this is where I see a big difference in our industry. There are people on one side which live in a medium, large organization, and they work in a relatively stable product. And they kind of know what are the things that they need to do next week, in a month, in 2 months. And things are pretty clear. And I would dare to say that this is the case with compilers, because compilers, yes, are a complex domain, but you kind of know what the features you need. At least that's what I would imagine. You know that you need to support a certain programming language. That programming language has certain features. When the programming language changes, if it's about C++, for example, C++ changes from time to time, but you get some idea of what will change years before it gets voted in the standardization committee and so on. And I imagine that there are similar processes for other programming languages. I'm not an expert in this. I did implement for fun interpreters and compilers, but it was a long time ago. It was really fun, but I haven't done that professionally. So we have on one hand people who work in relatively stable environments, and they tend to see this world, which is a more fixed mindset type of world. On the completely opposite end of the spectrum, we have people like Alan Holub, who often on Twitter talks about we have no requirements, or there is no notion of plan, there is no notion of requirements. Why? Because they believe that software development is about these areas that are unexplored and where you need to continuously discover. So where you have a kind of continuous discovery going on in the same time with the actual programming. So because this happens, the notion of requirements blurs out, right? You know you have certain problems to solve, and you kind of come together, contribute to solving those problems. You implement features, and that works in that context because your goal is to learn as quickly as possible what your users need and how you can grow your business. Your goal is not to implement something that is set, a list of things that you know will need to be in the product. And in fact, often if you know a list of things that need to be in the product, what you try to do is to reuse them, to use some external services or APIs or whatever for that, because that is not the important part. The important part is the rest. Let's say the secret sauce of your business. Now, when these two worlds start to discuss, there's a complete breakdown in communication. They are not talking the same language. They are not speaking the same language at all. And they kind of understand they don't. And sometimes you'll see that they admit that they don't, they are not that interested in this more stable world. The people working in the more stable world look at these other people and say, okay, this doesn't make any sense. What they are saying makes absolutely no sense. Why do we need all that when, we kind of know what we need to build? There's no problem. And I believe that it's really wrong to treat software development as one thing. It's not one thing. Depending on your context, it can be anywhere from one extreme to the other extreme. From extreme programming to waterfall, right? It can be anywhere around this. So this is just setting the context, okay? And I believe oftentimes the discussion about no estimates versus estimates was very heated because it involved these two worlds. One world that says, but we need estimates. They are actually helpful. If we do them, they tell us, budgets and when we finish things and so on and so forth. And they are actually quite useful. And the other world that says, we have no idea how to estimate something like that because it always changes and the estimation error might be 10 times larger than the estimate. So then it makes no sense to make an estimate. And of course, these two worlds collide because the estimate world would accuse the no estimate one of lack of responsibility, and the no estimate world would say about the other one, but you don't understand. There's no way you can estimate, and the message just doesn't get through either way. So I like to understand software development as a whole, and to me, my mental model is this. You have tools, you have a toolbox. In your toolbox, you add sets of tools, and you deploy those tools where it makes sense, where they bring value. And estimates are one such tool. Now, we discussed when estimates don't make sense at all. Now, let's talk when estimates would make sense, but they are still not as helpful as they could be. And let's assume that we are talking compilers. Okay, so you kind of know what's next. You can estimate. You can make Monte Carlo simulations. You can apply all the techniques that you said. But you have manager negotiation. And this is where things start to break down as well. Because I agree with everything you said, and I'm going to go back to all the things that you said, because they are very, very interesting, and I want to explain them for our audience. They can definitely help with solving a lot of things related to the estimates. But you eventually get somebody who wants to negotiate your estimate, and this is where things break down. So let's say you have a nice list of features and you do interval-based estimations and you run Monte Carlo simulations and you do all that. And you get that whenever somebody asks you, so how long do you think let's say we have a bigger feature that we need to implement. How long is this feature going to take? And you tell them, well, between 6 and 8 weeks. No, that doesn't work for me. I want it in 5 weeks. Okay. This is where things start to break down, because you did a correct job. But if somebody comes and, a manager or a customer, or they come and tell you, oh, no, but I need it it can be an invitation to negotiation, which can mean, okay, let's reduce the scope so that it fits, or let's cut down the risks. Because we can do certain things to alleviate the risks and so on. And that would be the good thing to do, right? And maybe you are working with reasonable people. Maybe they don't negotiate with the development team. Maybe they don't have, or they understand that they can reduce the risks by doing other things, or they understand they can negotiate the scope, and that's, at least, is better. But there are also situations when you'll have people saying, no, I want it like that, and all the feature, it has to be everything, but I want it in 4 weeks. You said 6 to 8, but no, I really won't need it in 4 weeks. And if that's non-negotiable, then why did you even estimate? I mean, because the other way around would have been for somebody to make their job as a product manager and say, we have this product, we have these questions about the product, or we have these opportunities for this product. Now we need this in the next 4 weeks. Right? We need to implement this in the next 4 weeks. And they come with this plan to you, and you look at it and say, okay, so we can do this if A, B, and C. And then you don't need to estimate, but you obtain the same result, which is get to the correct deadline. So this is another way in which you can deal with that. Also, what often happens is that people say, no, but we need that full feature. And then you start implementing, and 1 week passes, 2 weeks passes, 3 weeks passes, and then they look and they say, oh, it seems that you won't be ready with this in 4 weeks. Well, I mean, we kind of told you so, right? Okay. Well, I really need it in 4 weeks, but we can drop this part of the scope. And then you negotiate the scope at the end instead of negotiating in the beginning. This is, again, something that very often happens. Okay, so there are these dynamics that can happen in a team. And if you've never seen those, or if you work for a longer time in a team that is not exposed to such dynamics, then it's great. I mean, to me, if we were doing estimates, the perfect option would be we get the requirements, we do our job, we create an estimate that is interval-based estimate with a list of risks and with ideas to alleviate each of the risks. And we present that to whatever it is, project manager and so on, who then goes and discusses with the client and they negotiate. And our estimation is never put into question. It is taken as valid, but it is a starting point for a negotiation that takes place outside our team. I've always felt that this would be a very fair way of dealing with these types of problems. And then maybe you might be asked, okay, but if we solve the risk, then we can reduce that. Yeah, we can cut 2 weeks there, and we'll do that in 4 weeks instead of 6 to 8, and yeah, fine. Okay. So these are the different contexts in which estimates seem quite useless, to be frank. Now let's talk about when estimates can actually be valuable. So if you know the problem that you're trying to solve, you can design up to a certain point, how the solution would look like. And you have this option to come in and estimate. Maybe you are asked, maybe it helps you as well. Because honestly, having estimates is useful for setting deadlines, which are useful for motivation. I've noticed that when I was writing my third book, which was the first book that I wrote with an editor, and the editor asked me for a more detailed plan, like what chapters do I plan to write, a description for each chapter, an estimate for each chapter. And then based on that, they generated the timeline for the project. And the deadlines really helped me because I always remember, so I need to send the chapter by that date. And I would sit down, write the chapter, even if I was maybe tired, maybe I didn't have a lot of, I didn't really want to work on that. But it was really motivating. And in the end, I'm proud of that book because I built it. So I can definitely understand and I can definitely see estimates and deadlines being very valuable in the right context. So let's talk about this right context and what we can do. As you say, and now this is for you, if you want to, for you, the viewer, if you want to make any correct estimations for your projects, this is what you need to do. We have the recipes here, and they are really good. First, estimate is never a value. So when you are asked for an estimate, it's never 2 weeks. It's either 2 weeks with 60% chance, so a value with a probability, or easier to understand, an interval, 2 to 3 weeks. Now, in my experience, project managers hate this, but it is what it is, and middle managers. So yeah, interval estimates, 2 to 3 weeks. And as Yuger is saying, as first approximation of tasks probability distribution. What you're actually trying to do is to say, we have 50% chance of finishing in a week, 60% chance of finishing in 8 days, 70% chance of finishing in 10 days, 90% chance in finishing in 12 days, and 100% chance of finishing in, whatever it is, 14 days. And because of this, is 2 to 3 weeks. Okay? Ideally, you'd have a probability distribution curve between 2 and 3 weeks. But let's say 2 weeks is 20% chance. 3 weeks is 90% chance, and the probability distribution is there. And of course, you have maybe 10% chance of finishing before 2 weeks, and you have another 10% chance of finishing after 3 weeks. That's actually what you're trying to visualize. But that's too complicated for us. So best thing, interval. Next, do estimates quickly get out of date as new information is discovered? No doubt, that's why they need to be continuously updated. No, this does not take much time. And this is true. If you don't have to negotiate them, that's a big if. But if you don't have to negotiate estimates, then updating them does not take much time, because you might say, Okay, team, we just learned that the database we're using doesn't support the traffic that we need. We need to add some more features or something to fine tune this. This affects these types of tasks. Let's re-estimate them. And so you look at those and say it's not 2 to 3 weeks, it's 3 to 4 weeks, fine. This can go very quickly. Now, if you negotiate on every one of those and you have a manager who asks, yeah, but couldn't it be 2.5 weeks? Then it might take a long time. So yeah, you can work in an environment where this is very quick, and you should do this definitely when you get new information. Can technical risks ruin the project's and render or planning effort unnecessary? Of course, that's why in addition to estimates, we need to estimate risks and schedule tasks to reduce overall project risk. So the way I used to do that was we would have an Excel file with all the work breakdown structure, basically. So we had the features, we had the tasks, we had estimates for each of the tasks, and then for each of the tasks we also had a risk estimate, which would be small, medium, large, or no risk. And each risk estimate would come with an extra factor for the task estimate. So if your task was, I don't know, 2 to 4 days, but it had a large risk, you'd multiply it by 4 or something like that. Now, was this perfect? No, but it was good enough to give a starting point for a negotiation, because then the client, this was back when I was working in outsourcing, so I had to give this to our customer representative who will look at that and negotiate with the client, and the client will look and say, oh, so you say this is high risk. Oh, I see. So, but I actually don't need this. What if we remove this part of the scope? And we will say, oh yeah, that's true. That's exactly why that risk is. By the way, we always attached comments to the risk. So we had large risks and then a list of things that would influence this risk. Like, we've never used that technology. We don't have clear UI defined, and it seems like something very complex, and so on. So there were a number of things that we took into account. And then you have two options. You can, so as he says, estimate risk. You can schedule tasks to reduce overall project risk. Well, the first one would be to reduce the scope. If you reduce the scope pertaining to that part of the risks, then you cut down the risk. If you still need to implement that, the customer says, okay, we need it, then you can do a spike, so schedule a task to reduce project risk. So what you do is, okay, this risk is related to using a new technology for this. We've never used it. We don't know if this might work. And then you say, okay, so we can run a 1-week experiment in which we implement a prototype that does exactly this core feature with this technology, and we see whether it fits or not. In the answer is yes or no. Either it works or it doesn't, and then you reduce. That's how you reduce the risks, because once you have the answer, you can say, oh, actually it's much easier than we expected, or actually this technology doesn't support this, we need to look at other technology to try another one. So yes, you get estimated risks, reduce scope or schedule spikes. Very valid approach. And by the way, even if you're doing agile, same thing. What you do is you would start with the more risky part. This is one of the things you should take into account. When you have an unknown, a known unknown, you have a risk, for example, new technology. You do a spike, you see what that means, and then you feed that, the answer to that, into the next sprint. So this is the continuous adaptation of in Agile. Can projects that consist of multiple tasks miss milestones because of accumulated deviations in all tasks? Sure, that's why we should do Monte Carlo simulations of network diagrams to obtain reliable confidence intervals. Now, this is a more advanced technique, but it is a very cool one. And I wish we had more experiments using Monte Carlo simulations. I think you can do that in Agile projects as well, in Lean projects, because you have existing data and you have known flows through your applications, and you can define kind of what steps need to be implemented. You have types of tasks that you can figure out after 3 or 4 sprints. And based on that, you can actually run these simulations that tell you which is the likely time for finishing a specific feature. And often people say, yeah, in Agile we don't do this type of planning, but it doesn't mean that you cannot use predictive technologies in order to try together and then adjust those predictive technologies based on the real result. So, Monte Carlo simulations of network diagrams. What this basically means is you take, let's say you take your project plan and you say, okay, we have this task, you have another task that depends on this, you have another task that depends on these two, and maybe you have another one that depends on your first one, and so on. So you have this network. And then you randomly generate values. If the estimate is between, let's say, 2 and 4 weeks, maybe you generate values between 1 and 5 weeks, and you try to predict. You walk through the network until you get to the end of the project, and you try to see the date, the end date for finishing. And you run this with multiple random values, and based on those you'll get a distribution of probability for the end date. And yeah, there's definitely a method that would work. I really wish it were implemented in an easy way in conjunction with something like Jira, because you have all the data in Jira, and then you can extract that and start having more predictability. I don't think that in most cases, I would say software development is not that as highly unpredictable as we expect. The problem is that there are certain unknown unknowns and things that we don't take into account, the developers don't take into account when estimating, because they tend to be too optimistic. And that add up and delay the projects. against the predicted date. So I think that's the main problem, really. It's not that it's so highly unpredictable, with the exception of the domains that we discussed in the beginning, right? So there are certain domains, but my feeling is that around is like a normal distribution, right? You would have a few at one end which are where estimates don't make sense, a few on the other end where estimates are actually quite reliable and easy to make. But in the middle, you have this high variation in estimates versus actual. They result because, not necessarily because of underlying complexity, but more because of hidden factors that can be revealed through statistics. At least that's my intuition. So I tend to agree with you, Gary. Is software development a highly innovative activity which deals with new domains and high risk? Well, maybe sometimes. Personally, I say modern corporate developer experiences this 5% of his time at best. Yeah. So if you're talking corporate developers, most likely, yes. The teams I worked with in large organizations tend to be quite stable, working on stable domains. They tend to know what needs to be done, with some exceptions. The exceptions being teams that work in an entrepreneurship style, in internal startup styles, where they are trying to discover product market fit through product discovery, or where they have a product but maybe there's high competition, maybe they want to get into a new market or into a new country, and then they need to apply these other techniques that reduce the value of estimates. Right. So I think, honestly, yes, in most teams, in most organizations, most of the time, could probably do that. But there are some cultural factors, and this is where things start to get difficult. For some reason, managers expect a set date, a set value, and they don't want to hear about probabilities. They don't want to hear about probability distributions. Developers don't know how to explain that often. Developers don't know how to write risks, how to explain the risks, how to plan to reduce the risks. So I think it's a mixed bag, right? And because of that, we end up with situations where estimates just don't bring value. It's just, you go to a meeting, you say 2, your colleague says 4, you end up saying, okay, it's a 3, but then you get the product owner saying, no, but I want this in 1. So, and it really, really doesn't, it's dysfunctional, it doesn't work. So I agree that if you can work, if you are in a team where you can actually do this good work of making interval-based estimates, risk analysis, risk reduction, Monte Carlo simulations, then estimates are extremely valuable. You can use them. They are helpful because they keep your motivation. You know what you need to do at all times and by when, and this is really great. And well, there will be certain delays, there will be certain tasks that you finish earlier. That's fine, that's part of life. You won't be able to estimate precisely. The thing is, when you have a lot of things, this tends to cancel out the errors. Some of them would be faster, some slower. So the errors tend to cancel out over a longer period of time with more tasks. So yes, it's definitely a possibility. But let's not ignore the other contexts. If it works for you, perfect. But if you see other people who say, oh, that doesn't work for us, try to think of what their context is. That would be my advice. Remember, if there's one thing you remember from this video, remember this. In software development, we have a set of tools. Each tool has an applicability domain where it makes sense, where it brings value. Outside that domain, it doesn't make sense. It doesn't bring value. It may sound ludicrous to apply that particular technique. As a developer, it's still useful to know all of those techniques because you never know when you need to deploy one of them. But also don't expect as a developer that just because you know one technique, you need to apply it everywhere in every project that you end up. And I think this is the general message of this channel. Learn as many tools as you can, as many practices as you can, but know where to apply them and where to avoid them. Okay, what do you think about this? This was a pretty long answer video. It's been a while since I recorded such long videos, but I think it's pretty warranted. It was an interesting topic. What do you think? Let us know in the comments. And thank you, Yuger, for making these thoughtful comments and engaging with us. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.